Okay, so now we're on the other half. All right, now we're at the other side where now you're going to be given names and we're going to try to write formulas. So hopefully Mondays didn't, blow you away too much. And then today doesn't just, finish the job. But this is not the easiest thing in the world. So just be patient with me as we get through this. But remember, we're still doing binary, we're still naming or writing the formula for two things. And remember, the whole purpose of this is take these letters on the periodic table, put them together to make them happy, and then name them or write the formula. That's all it is. Okay. So we have to go back with what we did Monday, which is why we had to do Monday first. If we work our way backwards, if we see the name of something and we have to figure out how to write the formula, all right, we can't just look at the periodic table and say, okay, this is what's going to be because you're going to be given a name. So what we have to do instead is we have to look for one of three things, all right? We look for prefixes, the monos, the dis, the tris, the tetras, all that other kind of stuff. We look for the word acid. That's usually the pretty easiest one to do just because you see the word acid. Or you look for nothing. It doesn't have any of the three things. And that tells you what category you're in. If you see prefixes, we use monos and dis and tris and tetras and stuff like that in molecular compounds. You use the word acid at the end of acids because there was an H in front, all that kind of stuff. And if you didn't have either one of those things, you didn't write a name. It was just like sodium chloride. Didn't have any prefixes, didn't have the word acid in it either. All right. So here are our rules. Again, you can pause this, rewind it, listen to this as many times as you want. All right. I'm trying to help you out as much as I can. Okay. The rules are this. We're going to, for ionic ones, you don't see a prefix. So, like these are all ionic: calcium fluoride, magnesium oxide, magnesium sulfate, no prefixes and no acid words. Okay. We're going to write the cation. Now you got to go back to what we did before. Cation is the positive ion. You're going to write the anion. That's the negative ion. So here's how it works. The reason why I do this in order. Calcium is a metal, and that's always going to form cations. If you look one to the other, all that kind of stuff, you can see it work. Fluoride, the second one, is always going to be the non-metal, which is the anion. Right? Always wants to form negative ions. So for calcium, you look on your little chart, and it should say Ca plus 2. You guys should have a little plus 2 like I do written above your chart. Now it's kind of hard to see, and there's calcium in that row. Fluoride, remember it had that ID ending. We're going to look up fluorine. Fluorine is right here. Again, if you understood Monday, we changed the ending to IDE, which is why you see these. Okay. Fluorine is right here. It's got a -1 charge. So there's write my cation, write my anion. Now, we're going to crisscross applesauce like you did in middle school or elementary school, whatever it was. The charges become the subscripts. And I guess I should put opposite subscripts, I suppose. Add it in here right now. All right. Let's put opposite. Become the opposite subscripts. Now, subscripts, remember, are the numbers that go down, tell you how many of those things we had. We talked about that a little bit last week with the polyatomic ions. So what you're going to do is this. This is all you got to do. The 2 goes this way. The 1 goes this way. Now, this is the hardest thing my kids to understand. The charges don't go with them. All we're trying to do is tell how many of these things we have. If that's too much for you, it's okay. Just follow what I'm going to do next. All right. So the Ca gets a 1, which we don't have to write, but I'm just going to do it for now. And the F gets a 2, becomes subscripts. And that is my chemical formula. Chemical formula calcium fluoride is CaF2. Again, because we don't like to write the 1 because we're lazy, just like you guys are. We're seriously lazy. All right. You have a couple rules. Reduce if necessary. All right. Because if you think back to putting the two ions together to make them happy, sometimes 1 and 1 makes them happy. And so you got to make sure you're okay with that. We'll show you an example of that. And if polyatomics are involved, you need to wrap those polyatomics and leave them alone. So I'm going to have my examples here. So there's calcium fluoride, CaF2. That's it. All right. Now, go to the second one. Magnesium oxide. So I write my cation. Magnesium has a +2 charge. Oxygen has a -2 charge. We're going to take our charges and crisscross them. They become the opposite subscripts. But now I have to reduce if necessary, if possible, really. 2 and 2 cancel out. So they're just going to go away. My formula is just MgO. Now, I get this all the time. What if I leave the 2's there? It's wrong. I'm sorry. It's just part of the rules. So you got to reduce if necessary. If you can reduce them, reduce them. 2 and 3 won't reduce. 1 and 2 won't reduce, but 2 and 2 or 2 and 4 or whatever are going to have this problem. Okay. Now, what about something with the polyatomic? Remember polyatomics, sometimes if you learn this from last Friday, can have ITE or AT endings like we talked about with the acids. So if you see something like sulfate or sulfite or nitrite or something like that, you're going to have one of these polyatomic ions involved. All right. So here's magnesium. Again, we're just going to follow our rules. +2. Now we're going to write sulfate. Remember, we're going to wrap our polyatomics. So here is SO4 because that's sulfate. We're going to wrap it. And now we're going to leave all the stuff in here alone. There's my charges. The charges become the opposite subscripts, not anything inside your parentheses, and becomes Mg2. There's my polyatomic wrapped with the 2 there. And then I come back up here and I can still reduce that. And those go away. There's my formula for magnesium sulfate. That's going to take some practice, okay? And we'll go over a lot of that on Friday when we start talking about how well we did on this worksheet. But that's how you do it, right? The first one with discharge, cation. Write the anion with discharge, cross them. Remember, just numbers go down, charges go away, they disappear in the formula. You never, ever, ever will have a charge in a formula, all right? Ever. This is not how that works, okay? Because the whole purpose of making this formula is everything balanced out, so the charges all cancel each other out, all right? Everything's good, okay? If reduce, like the 2 and 2 canceled, and wrap polyatomics and leave alone if possible, okay? You can do that. Okay, so let's get rid of these here for now. Again, have these rules up here and just write them somewhere where you can follow along. You should have a page with your naming rules and changing their writing formulas too. So, molecular, if you see prefixes, no crossing. We're not going to do the crossing we just did here. That's why I had to put it here, so I taught this part first. The prefixes and they become subscripts, excuse me. Diphosphorus pentaoxide. Phosphorus is P, oxygen is O. Di, remember what prefix di stands for? It's 2. Penta is 5. There's my formula. Literally, that's all it is. Diphosphorus P2, pentaoxide O5. Okay, you have to memorize those things because it's right there. Okay, so let's go back to the one you guys know. Just make it simple. Carbon dioxide, the stuff that you exhale every day. C and O, but the di tells me I have 2 of them. There's CO2. And that's all you got to do is write your formula. That's all you're doing. Do not reinvent the wheel. Don't do anything that I'm not asking you to do. Just do it that way and you should be okay. Okay. Last set of rules are acids. And again, acids kind of stink because you got to break them into 2 categories. So I get that. But remember, acids are special kind of ionic compounds. They just happen to have an H in front. We talked about that in our rules for the last time. Okay. So the deal is this. The first rule for both of these, whether you have the word hydro or not, is you're going to cross H+1. That's going to be your cation ion. Cross H+1, H+1, whatever it is, okay, with some kind of anion or some kind of polyatomic ion. So we go back to the rules we had in naming compounds. If we had hydro, we didn't have any oxygen. If we had no hydro in front, we had oxygen. We had one of those polyatomic ions involved. So here, we're going to cross it with some kind of element. And here, we're going to cross it with a polyatomic ion. And again, you can watch this 17 times for all I care. You can email me questions of things. And on Friday, we're going to go through that worksheet that I'm assigning and see how well we do. Okay, that's the whole point. So here's my example. Hydroiodic acid. All right, you got to be real careful how you pronounce this because yeah. Okay, so hydroiodic acid has hydro. So we are simply going to cross H+1 with my anion for iodine. Because remember, the IC went back from iodine. Well, iodine is just I-1. It's a cross. 1 and 1. Hi. Literally, that's all it is. That is literally all it is. Okay? Don't reinvent the wheel. Okay, let's try something else. Let's go hydrosulfic acid. Hydro means there's no O. Acid means we're going to cross H+1. Sulfic came from sulfide, so I go to my chart. Because if I see hydro, I have to go to my chart. Sulfur is right here with a -2 charge. Okay, 2 goes there, 1 goes there, makes H2S. Now, why didn't I put reduce if necessary? You're never going to reduce an acid, ever, because you're always crossing the H+1, so it's always its smallest form that you guys have to worry about and do, okay, when you guys do that. So that's that one, okay? So that's the hydroiodic acid part. We just give an example for that, and you miss it, rewind this. Okay. So let's talk about the last one. If you do not see the word hydro, like tartric acid, all right, you're going to cross H plus 1 with some polyatomic ion. Remember, polyatomic ions, IC, came from ATE endings. OUS came from ITE endings. Okay. So I'm not going to look up tartric. When I don't see a hydro, I have to go to this chart. This is my favorite chart right here. Tartric. I'm going to look up IC, change to AT. I'm going to look up tartrate. And most of you guys have never heard of tartrate before, and it's okay. Okay. And here's the deal. I'm going to cross H plus 1 with tartrate. So I'm going to find tartrate. Just like here, I'm going to wrap them and leave them alone. C4, H4, O6, wrap it. There's my charge on the outside. Okay, I'm just looking at copying down right from this thing right here. So I crisscross. 1 goes down, 2 goes over and becomes H2, and then C4, H4, O6. That is my formula for tartric acid. Now, this is where it gets confusing a little bit. This is why we have to wrap our polyatomics and leave alone. Remember, you're never going to reduce these. People think, oh, I can reduce these. I can cut them all in half and it'd be perfect. Yeah, but then you don't have tartrate anymore. So that's why we wrap these polyatomic ions and leave them the heck alone. Okay, going through that, whatever. All right. Now, last thing I want to talk about. Okay, and I'm telling you, we're trying not to make it really hard for you, whatever. But going back into here, you might see things called iron 3, Roman numeral 3, chloride. Now, nowhere have I mentioned using parentheses or using the Roman numeral or stuff like that, because that's that hate box stuff. But yet, I can't go back and change stuff that people already did. If you see this, if you see a Roman numeral somewhere in your formula or your name, it means it's in the hate box. And they don't have a rule. See, like here, we have like +2, +1, +3, +4. You know what category you're in, but in this hate box, you're not sure which one you're in. Okay, you're not sure. These are those transition metals. You remember back a couple weeks ago. So they could have different charges. So I have to tell you what charge they are. Notice though, it's going to fit in this rule. No prefixes. No prefixes. No over here. So I'm going to write down my ion, which is Fe +3, because that's what that told me. Roman numeral 1 is I is 1, II is 2, III is 3, IV would be 4. And chlorine, again, still -1, so we still cross. And it makes FeCO3 would be my formula. Okay, so I just wanted you to see one of those before we left off. So your homework for today, this is Wednesday's homework, is this half of the worksheet, 21 through 40, where I give you the names and you try to follow the rules. And again, just do your best. We're going to go over some of these on Friday. That's the whole point of this. I want you to see what you do. I want you to try to name these last 20. So this was your assignment for today, for Monday. This is your assignment for today on Wednesday. So this worksheet is the one you need to do. All right. I just kind of in there. If you have any problems, let me know. Sorry, I'm having a coffee. All right. Have a good day, guys.